All right, guys, this is what it is all about. We're no longer just looking at a dinky equation. We're not just looking at the picture of the graph. We are going to put these things with real life situations, with things that are really happening, models that actually work. That's the whole point of all this algebra stuff. That's the point of all these equations, is the purpose of all these lines, is trying to represent something that's really happening so that we can predict what's happening before, we can predict what's happening afterwards, we can predict what's happening anywhere in the middle. That's the whole point of all of this. So let's take our first question here. Cheerleaders at football games often launch t-shirts into the crowd when their team scores. Yay, t-shirts! What? Our team just scored? Yay, t-shirts! I mean, I've seen people like kill each other over a t-shirt. I mean, sure, when their team loses, they're angry, but when they don't get the t-shirt, when the other guy gets it, man, they get mad. Anyway, so we're looking at the height of this t-shirt being modeled by the function h of t equals negative 16t squared plus 48t plus 6, where t is time in seconds and h is height in feet. Okay, so t is time, that's going to be important, and h is height. All right, so I'm actually going to underline those because that is going to be important. H is height in feet. All right, and time was in seconds. The graph of this function is shown below. Answer the following questions. What type of function is this? Now, you should be able to look at this graph and know what type of function it is. If you can't tell by looking at the graph, you should be able to look at the equation here, right? Now, if you look at the equation, you've got a t squared and you've got a t. So the temptation to say, well, it's either quadratic or linear. It can't be both. A line cannot be both a straight line and a parabola at the same time. It's one or the other. The general rule of thumb is if there's only the t, then we'll call it linear. If there's something else, it's going to be that other type of function. So this is a quadratic function. All right, now we go in. What is the y-intercept? So we're going to go, y-intercept is right there where it crosses the y-axis. That is also where x is 0 at that point. So the y-axis, so that would be 0, 6. Now it says, what is its real life meaning? Okay, so now what we're going to do is we're going to take this 0, 6 and put it into words, write a sentence for it. And so we're going to say when x, now what's x? Well, x is time. So when time equals 0, now y is the height, right? That's the height, so the height is 6 feet. Now I can do better. That's okay, but even better is to say before launch, or at the time of the launch, at the instant that it's launched, the t-shirt is 6 feet above ground. Okay, so we've got good, better, best. Good is recognizing that it's 0, 6. Better is being able to put time and height in there. And the best is to be able to say, you know what this is really telling me, this y-intercept, this 0, 6, it's telling me that as the shirt is being launched, before it gets launched, that instant before he pushes the trigger, it's 6 feet above the ground. That makes sense if you got a really tall cheerleader. He's holding it up in the air about 6 feet up. All right, what is the x-intercept? So there it is right there. Now I note that there's 4 in between 0 and 1, so that means each one is 0.25. So this right here is 3.25. So it looks like it's somewhere between 3 and 3.25. Maybe I'll call it 3.15. So I'm going to say the x-intercept is the y value being 0, the x-intercept being 3.15, approximately. All right? What is its real life meaning? Well, what does 0 mean? Oh, man, just kidding. It's 3.15, comma 0. Just checking to see if you were paying attention. Hopefully you were. Anyway, so 3.15 is the x value, and 0 is the y value. I even said that when I wrote it down. Man, I'm such a dork. Anyway, so 3.15. Now, what does that mean? Well, this is time. So time is 3.15 seconds, and y is 0. Remember, y is the height. So if y equals 0, and that's also the height, what does it mean if the height is 0? It means it's on the ground. So at 3.15 seconds, the shirt hits the ground. Okay, that's what's really happening at that x-intercept. Okay, what is the vertex? Okay, vertex, so I've got 1, maybe 1.5 there. It looks to be about 1.5, so 1.5. It looks like maybe it goes, these are going by 2, 4, 6, 8, 10, so it looks like it goes up to about 42. So the vertex is 1.5 comma 42, which we can identify. Is it a maximum or a minimum? It is a maximum. And what is its real life meaning? The maximum height is, what's the highest it goes? 42 feet. And then if you want, you can even say after 1.5 seconds. Okay, so 1.5 seconds after the launch, it's at its maximum height, which is 42 feet. That vertex is loaded with information. It's got time, it's got a maximum height, it's got some good stuff in there. All right, now we go on to domain and range. So remember, domain are the x values. Now, quadratics, usually when we're just dealing with some random line, the quadratic has a domain of all real numbers. That's not the case here, right? Because we don't go into negative time, and the graph doesn't show anything past what I labeled as 3.15. So that means that x, and I'm going to put it in between these numbers. What's the lowest x can be according to my picture here? Well, 0, right? We don't know what happens before that. So this quadratic function is only valid starting at time 0. And then how high does it go as far as the x value? So how far to the right? Well, it goes up to 3.15. And so that is your domain. All right? So now we look at the range. Range is the up and down. So again, we look at y. Y has boundaries. Okay, so we say how high does it go? How low does it go? So how low does it go? What's the lowest that the t-shirt gets? Well, it's on the ground when the height is 0, right? So we say, okay, that's the lowest that it goes. And then the highest, the biggest value for y. So we go up, 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 up. Oh, there it is, and we already named that before because the vertex was 42. So 42 is the highest height. So what does this tell me? It tells me that the time is valid between 0 and 3.15 seconds. And it tells me that the height can be anywhere between 0 and 42 feet during those 3.15 seconds. So the domain and range also have a real-life meaning, and they describe something in specific. Okay, so that's your first question. That's number 3 in your worksheet. Go ahead and watch the other video.